we were discussing about sequence and series, and in particularly sequence, we were discussing geometric progression, right? So let's move the discussion forward. A geometric progression, any two consecutive terms having common ratio, that particular sequence will be known as geometric progression. The condition for three terms to be in geometric progression is b square is equals to ac, where b, if we find out b here, then b is square root of ac, which is also known as the geometric mean of a and c. Okay, if you have to find out the geometric mean of a and b, that will be square root of ab, simple, right? So if that is clear, let's move ahead. We have also discussed about the sum of n terms, which is this formula when r is less than 1. And when r is greater than 1, then this formula is used to find out the sum of n terms in GP. To find the nth term in GP, we can also use this formula. Clear?
Yes, sir.
Great. Anyone else have any doubt from previous class? No doubts? Great, that's great. So GP is a sequence of numbers whose first term is non-zero. It should be non-zero so that other terms can be different. And each of the succeeding terms is equal to the preceding terms multiplied by same constant. And that same constant is common ratio. Thus, in a GP, the ratio of successive terms is constant. This constant factor is called the common ratio of GP. Therefore, GP is AR square, AR cube, AR4. That's how typically a general GP goes on, where A is the first term and R is the common ratio. We have already discussed about the nth term and also about the formula for finding out the sum of n terms in GP, and also how to find out the nth term when we have sum of n terms and sum of n minus 1 terms. Okay, discussing about the sum of infinite terms in GP, we are able to find out that only when the common ratio is less than 1. So the formula for the same is A upon 1 minus of R. We have discussed why it is so in yesterday's class. We have also taken one example where we find out the sum of this particular infinite GP. Any doubts? Everything clear?
No, sir.
Okay. So let's now discuss about the assumption, as we have discussed about what terms to assume in case of AP. So similarly, convenient assumption, case of convenient assumption. If you have to assume three numbers, like for AP, there was 1, 2, and 3, or maybe 3, 4, 6. Okay. For GP, you can take numbers like 2, 4, and 8. The common ratio is 2 here. Okay. Or you may also take 1, 2, 4. Any assumptions can be made. Okay. They are all in GP, they are in AP. Or here also 3, sorry, 2, 3, 4. Why I am ignoring 1? Sometimes, because sometimes it may happen that taking 1 will not be convenient for you. For solving some particular expression, they may become not defined. So accordingly, you can act. Only you will be able to understand this point when you will have to use them. Okay. What if we have to use, we have to assume some terms in GP, let's say 3 terms. So for assuming 3 terms, simply assume one term as A by R, another one is A, another one is AR. Notice happening here, if we take the product of all these 3 terms, the product will be A cube and R will be cancelled. That's why we are conveniently doing so. If there are 4 terms, now there are some changes. We'll now consider the first term as a by r cube. Now this time we will take the common ratio as r square. So this becomes a by r, this becomes ar, now this becomes ar. These are four terms. If we take the product of all these four, the product will be a raised to power 4. This time the common ratio is r square for sure, but also we have taken that 4 so that when we take the product of all these four terms, then r will be cancelling out of the equation and we'll be able to find out the answer, the particular answer for A easy. Clear? Same it will happen ahead also. For finding five terms, we can add one A by R square here and AR cube here. For finding six terms, we can add A by R raised to power 5 here and AR 5 here. Clear? Any doubts? No doubts?
No, sir.
Okay, then let's move ahead and discuss the properties of geometric progression as we have discussed the properties of AP. So this time, if you add anything like there is a GP, if you this time multiply it with any constant number or divide it with any constant number, the resultant sequence will also be another GP with of course a different constant. Sorry, with of course different terms, but the sequence will be of same nature that will be also in geometric progression. Okay, but when you divide by k, so that number should not be 0. Let's take an example. Let's take this GP only 1, 2, 4, 8, 16, 32. This is a GP. The first term is 1, common ratio is 2. Now let's multiply the complete GP by 3. Okay, whatever will be coming, that will also be in GP. Let's check how. So this 3, the second term becomes 6. Fourth term will become 12, 24, 48, 96. Clear? So this is the new sequence. If we check if this is the sequence in GP or not. For finding out that if the common ratio of two consecutive terms are equal. So checking 6 by 3, 12 by 6, 24 by 12, 48 by 24, 96 by 48. Yes, the common ratio is 2 and it is the same everywhere. Clear? So that's why this is also in GP. That was originally in GP. So similarly, we can also find out for any example with division, but that number has not to be 0. Otherwise, the sequence will become undefined. Any doubts, anyone? Any doubts?
No, sir.
Let's discuss the next property then. Like if we are taking reciprocal of whole the GP, this was the original sequence given to us. And if we may write 1 by GP, given that no term in the GP is 0, no term in the GP is 0, then the new sequence that is formed, this will also be a GP. Right? Let's say 1, 2, 4, 8 is a GP. It is a GP. We write 1 by 1, 1 by 2, 1 by 4, 1 by 8. This is also in GP. Let's check how. 1 by 2 divided by 1 should be equal to 1 by 4 divided by 1 by 2. 1 by 8 divided by 1 by 4. Now this becomes 1 by 2. This becomes 2 by 4, which is 1 by 2. This becomes 4 by 8, which is 1 by 2. So yeah, 1 by 2 is the common ratio here. And this sequence is also GP. That's how this property is staying true. Any doubts, anyone?
No, sir.
And I request whole of the class to respond, okay? Keep on interacting, Guru and
What else?
same if we take any particular terms from the GP on a regular interval, then the new sequence formed from that particular taken terms that will also form a GP. Let's consider an example to understand it. Okay. So if we take terms after every two terms or three terms, let's say this is the one. So the new sequence is 160 and 256. Now we have taken after a regular interval. So this will be also a GP. This is what the property says. Let's check it. So for these three terms to be in GP, the square of the middle one should be equal to the product of the other two. So what is 16 square is 256 only, right? 256 is equals to 256. Yes, it is true. Clear? Any doubts?
No, sir.
Great. So this is what the property says. And there's one more property. There's one more property. If we raise power, like if there is a GP, if we raise its power to like except zero to anything else, any number, any integer, then the new sequence form will also be a GP. Clear? Let's take an example. Let's say we have a GP. This is the GP. 1392781 243. If this is the GP, if we take it square, then the new GP that will be forming will also be I don't know the squares of these two. So this new GP that will be formed will also be a GP. The new sequence is also going to be a GP with different common terms. So with different common ratio and the first term, of course. Okay, clear? Any thoughts?
No, sir.
No, sir.
Great. So discussing the next property. Now this is very unique. Let's discuss the unique property later. As we have discussed in for APs that if any two numbers sum was like this is 8 1, then it can be written as equals to this because the sum here and here is equal. That was for AP. Now this time for GP, instead of this applies in sum. So let's say S2 is 11, so the sum is 13. So S6, S7, that will be equal to the product of sum of 6 terms into the product of sum of 7 terms. Or we may write it as 13. So we may write it as S3 and S10. Okay. So basically the gist is that the sum should be equal. If the sum of these two terms, these two numbers are equal, then their product of the sum are also going to be the same. Clear? Why it is happening so? Because this time the power is getting added. Clear? Clear? Any doubts, anyone?
No, sir.
Yeah. So, okay, let's discuss the unique property. If there is any GP, okay, and we take logarithm of this GP, then it becomes an AP. Let's take an example to understand it. This is what? A GP. If we take logarithm of this whole to the base 2. Okay. So now logarithm of 1 is what? Logarithm of 1 to the base 2. Logarithm of 2 to the base 2. Logarithm of 4 to the base 2. Logarithm of 8 to the base 2. Logarithm of 16 to the base 2. Logarithm of 32 to the base 2. Now this has become an AP. Let's solve it how it is. Logarithm of 1 to the base any is become 0. This logarithm of 2 to the base 2 is 1. Logarithm of 4 That can be written as 2 raised to power 2, like 2 square. Now 2 will come ahead, and logarithm of 2, that becomes 1. So 1 into 2 becomes 2. Similarly, 2 raised to power 3. Similarly, 2 raised to power 4. Similarly, 2 raised to power 5. Now we know this is the common differences of 1 here. That's why this is an AP. Clear?
Yes, sir.
This is unique property. If we take logarithm of any GP, that becomes an AP. And if we take anti-log of any AP, that becomes any guesses? Anti-log of any AP, that will make it a GP group, geometric progression. Clear?
Yes, sir.
Okay, so let's now discuss about geometric mean. Mean is basically average. So if you want to find out some mean of some terms, let's say there are terms E, B, C, D, E, and going on. So if there are these many terms, you want to find out the geometric mean of the same. So you have got to multiply them all. Multiply the whole terms. Okay, all the terms. And let's say there are n terms here. So considering there was n terms here, you multiply them all and raise its power to raised to power 1 by n. Okay, that's how you are going to find out the geometric mean. Let's take an example. Let's take a case if there are two numbers only, a and b. So geometric mean of them will be a into b, product of whole, divided by 1 by n. N is, there are two terms only. So this is basically square root of a. Geometric mean of three terms a, b, c, that will be product of whole raised to 1 by 3. So the cube root of ABC is the geometric mean. Clear? Any doubts?
No, sir.
Yeah. So let's discuss about the insertion of geometric means. Geometric means between A and B, and what is its objective? To make a sequence, to make a GP. Okay, by inserting, like there are A and B, and we are inserting some geometric means in between them. And now this new sequence is in GP. This is our objective. Clear? So likewise, as we have done earlier, we know one thing for sure, that the geometric mean of A and B has to be equal to the geometric mean of the middle terms. This is one thing, very important. Clear? As we know here, how many terms are there in the GP? These are n terms. And there are left two terms. How many total terms in the GP? N plus two terms. These are n terms in A and B. So one term is A and another term is B. So there are two terms addition. We know that there has to be some common difference, right? So let's try to find out this, the nth term, the last term of this GP. So if we try to find out B, A, the first term, into its common ratio raised to power n. So what is its position? N plus 2. No, n plus 2 minus 1, because the nth term of any GP is a raised to power a into r raised to power n minus 1. Now this time the positioning of this is n plus 2. Okay, so this becomes n plus 1. 2 minus 1 becomes n plus 1. Clear? Any doubts? Any doubts?
No, sir.
So we can write b by a is equals to r raised to power n plus 1. So if we further simplify it, R becomes B by A. Now, if the power goes to the other side, power will be written in reciprocals. This is the common difference. This is important. Now, similarly, G1 will become A into R. G2 will become AR square. AR square. Similarly, we can write the nth geometric mean will become A into R raised to power n. This is a special case. That's all you need to know. Clear? Any doubts?
No, sir.
Please observe the slide. Important. Let's take an example, and I want you to find out. First of all, the given GP is Gn. Okay. Now find the geometric mean of G1, G2 till Gn. Using this earlier formulas itself, you will be able to find it out. This is 1 by try. Hold. Any answers? Simple. As we have talked about earlier also, the geometric mean of A and 1 by A will be 1 into 1 by A raised to power half. And the geometric mean of that we have to find out will be equal. So now this becomes 1. 1 raised to power half becomes what? 1 only, right? So this is our answer. That is. Clear? Any doubts? Basically,
No, sir.
basically, there are always no doubts, but please have some doubts. So basically, the geometric mean of these two terms and the terms between them are equal. So same concept we have applied here also. The geometric mean of these two terms and the geometric mean of the remaining terms has to be equal. this is what we need to find it out, and we find it out the geometric mean of the first and last term because their product was becoming 1, and hence 1 raised power anything is 1 only. That's all. Clear? Clear?
Yes, sir.
Let's
Sir.
now go to another important topic, which is recurring decimals. So, as we know, real numbers, there are rational numbers. Rational numbers are also two natures. There are irrational numbers. There are some decimal numbers, decimal terminating decimal numbers, and there are some non-terminating but repeating decimal numbers. And there are some non-terminating, non-repeating decimal numbers, and they are irrational numbers. Today we are going to discuss about non-terminating decimal numbers who are not just getting terminated, but they are repeating numbers. They have some repetition in them. Clear? Any doubts about real numbers, rational numbers, and what are irrational, what is non-terminate, what is not repeating? Any doubts?
No, sir.
Still, let me give you an example. A decimal number like this is terminating decimal number. A decimal number like this is a non-terminating decimal number. This is basically it goes on till infinity. This is non-terminating but repeating. Okay. There are some non-terminating and non-repeating decimal numbers also, like pi. They are irrational. They'll just move on like this. Some numbers will keep on randomly coming. Okay. So we are going to discuss these numbers today. Clear?
Yes, sir.
As they are part of rational numbers, so we will learn how to represent these numbers in rational numbers, or we can write them in p by q form. So let's start by taking an example first. Okay, let's start by taking an example. Let's say we have given this number x is equals to 2.357, and this bar on 357, all of the decimals. Now, how shall we find out its rational form, right? So first of all, we'll understand and expand this number. Now this means that 357 is getting repeated. So let's write the bar over here. That is the same, right? Do you agree with this step? That the 357 will keep on repeating. So we have repeated once and then have put it the bar. So it's the same, right? Clear? Any contradictions? Hello, is everyone awake? नहीं समझ में आया? Should I explain? I can explain.
How could you explain?
Yes. So what bar means that 2.357 on the bar means that the digits under this bar will keep on repeating itself. So 357, 357, 357. That's why we have kept this bar. Similarly, like if you divide 10 by 3, then what will come? 3, 9, 1, and then taking in decimal 3910. So basically 3333 will go. So instead of writing 3 for infinite times, we represent it by 3 point by a bar on that particular decimal, and it represents that it is the equivalent of writing this. Now, are you able to understand that what is the significance of the bar? Clear?
Yes, sir.
So similarly, what we are doing here also, instead of writing 357 again and again, we have put it a bar over there. Okay. Clear? So this is basically x. Now let's multiply x by three numbers. By three zeros. Why three zeros? To make one pair of as many numbers are there under the bar, we are going to multiply the number of zeros to it. How? By applying 1000x, and that will make it the number 2. Now the point will shift three numbers backward. 2357 point 357 357 357. Let's keep on repeating, right? Do you agree that how the decimal has shifted three places to the right? Clear? Or should I explain?
Yes, sir.
If you multiply by 10, so what will it become? 5320. Now decimal will be placed after two digits. So that's how by multiplying 110, the decimal is shifted towards it, right, by one place. So if we increase the zeros, decimal will also place itself further. So that's the point. Basic. So now 1000x. Now let's represent 1000x better. 357 is getting itself repeated. So why not writing 357 like this? Agree? Everyone agrees? Any doubts?
No, sir.
So now let's do one thing. Subtract the second equation from the first. On the left hand side, what will be left was 999x. On right hand side, we are basically subtracting 2.357 bar. Now you can tell me this will cancel each other, right? And this will become 2355. Any doubts, anyone? This is a critical step. Any doubts?
No, sir.
Okay. Now we will be able to find out the value of x, which is 2355 divided by 999. This is our rational number that was required to be found out. Clear? Now please observe all the steps once again. 10 seconds. Done?
Yes, sir.
Let's take one more example. Now this time the x is 0.1418. Now the bar is only on these two numbers. Now we have to find out its rational number. So first, let's make it a normal pattern that we have solved for by multiplying 100 both sides. That becomes 14.18. There is a bar over it. Now we are looking on it from a fresh perspective. So there are two digits under the bar. So let's multiply with two zeros. So the decimal will shift one place and 18 will still be left. Now this time, let's subtract this equation and this equation. 2 minus 1. On the left hand side, that will become Clear? Any doubts? 10,000 minus 100 becomes 9,900x. This becomes 1408 minus 14. So that becomes 1394, if I'm right. Clear? 1408 minus 14. 8 minus, oh, blunder. That becomes 4. And that should become, and that should become 1394. Okay, that's right, right? Am I doing a mistake? No mistakes?
No, sir.
Yes. So the x will become 1394 divided by 9900. Now notice one thing, that how we have tackled, there were different digits without having any bar. Observe please. Done? Any doubts?
No, sir.
Okay, then let's take one example of the property that we were discussing. This property of assumption. There's a question that find three numbers in GP. Okay, find three numbers in GP having sum 19 and product 216. Okay. So we have to find three numbers in GP having sum as 19 and product as 260. We do not know about any first term or combination. So let's now assume three numbers. If we have to assume three terms, we can assume A by R and A into R. Now see the convenience of this assumption. The product is 216. So let's multiply them all. R cancels R. That becomes A cube. Now what is the cube of 6? 216, right? 36 into 6. 216. So A is 6 for sure. Okay, if A is 6 and there's also one more thing given that the sum of all is 90. We know that A is 6. So we can take A common 6, 1 by R, 1 plus R into 90. 1 plus R, 1 plus 1 by R plus R plus 1 is equals to 19 by 6. Okay. Let's solve it further. And 1 by R plus R becomes 19 by 6 minus 1. So minus of 6, that becomes, let's solve it on next page. 1 by R plus, sorry, 1 by R plus R becomes 19 by 6 minus of 1, that becomes 19 minus 6. So that becomes 13 by 6. 13 by 6. Okay, okay. So by looking at itself only, we are able to understand that what is the answer. Anyways, let's solve it also. Okay. So there are two, let's take R common. R is LCM, 1 plus R square, that becomes 13 by 6. Cross multiplying 6 plus 6R square is equals to 13R. 6R square minus 13R plus 6 is equals to 0. That we write properly. 6R square minus 13R plus 6 becomes 0. This is a quadratic equation. Now let's apply the Sridharacharya formula. R is minus of B plus minus root B square. 13 square 169 minus 4 into ABC. 4 into BC. Sorry. B square minus 4AC. That is A and that is C. So 4 into 36 divided by 2A. 12. 36 into 4 becomes 144. I'm correct. So 169 minus 144 is 25. Square root of 25 is 5. R can be 13 plus 5, 18 by 2, that is 9. 13 minus 5, that is 8 by 2, that is 4. There can be two values for R. Clear? Sorry, that was 12, not 2. Idiot. So 13, here is 12, here is another 12. So 18 by 12 is 9 by 6. And further solving, like it is in the table of 6 only. So 6 3 is 18, 6 2 is 12. 4 1 is 4, 4 3 is 12. So 3 by 2 and 1 by 3. Uh, sorry, 4 2 is 8. 3 by 2 or 2 by 3 has to be R. Okay. So let's now try finding out three numbers. We have find it our three numbers are A by R, A and A by R. A we have find it out as A we have find it out as 6. So let's find out A by R, assuming A is 6 and R is 2 by 3. Let's assume the case number first. 6 by R is 2 into 3 into 6 into 6 into 2 into 2 by 3. So that becomes 6, that becomes 3 into 3, 9, 6, and 3 twos are also there becomes 964. Or let's assume A is square 6 and R is 1, R is 3 by 2 this time. So they will be same actually. 1 by R is equals to R. So that's why this term should be same. Anyways, A by R 6 by 3 into 2 into 6 into AR 6 into 3 by 2. So that will become 6 into 2, 12 by 3, 4, 6, and 18 by 2, 9. So 469 or 964, they are the same three numbers. So we have to find three numbers, that is 469 is the correct answer. Any doubts, anyone? This is how conveniently we have assumed A by R, A and AR. That has helped us out to solve this question. Clear?
Sir,
Let's take one more example of GP. So this particular example says that we have to find out 7 plus 77 plus 777 plus 77777. Like this, it's going ahead up to n terms. Wow. So we do not have to give any exact answer, but we have to find out its formula for sure. So let's observe. So what is one thing common between them all? Is this an AP?
7.
Yes, 7 is common for sure. But is this an AP? Is there a difference common between two consecutive terms?
No, sir.
Are they in GP? Is there any common ratio? No, 77 by 7 becomes 11. Now 777 by 77 is not solving for 11 for sure. So let's try to figure out and simplify the given sequence. So it is for sure given only that 7 is common. So 77 divided by 7, 1. That also 1, 1, 1, 1, 1, 1, 1, 1. And similarly up to n terms. So, sorry, the nth term will be n times 1. Anyways, now we can better write these many terms. So, can we break down 11 as 10 plus 1? Yes, please respond. Can we break down 111 as 10, 100 plus 10 plus 1?
Is it 1 common again?
Yes, 1 is common, but we cannot. What's the use of taking 1 common? So that's why we are trying to figure out something else. So can we write this as 1000 plus 100 plus 10 plus 1? Yes, we can do that. So we are looking one thing that is common here is is one thing for sure. For the second term, 10 raised to power 1 is coming out plus 1, the earlier term. 10 raised to power 2 plus 10 raised to power 1 plus 1. So what we are observing, but there are like three terms. So it would be better if we can take only two terms because then it will be convenient for us to make a pattern. Here, making a pattern will be hard because every term is expanding to give another four term. So instead of that, if we write 10 minus 1, so instead of this, if the term was like this, so we can now give only two terms. 100 minus 1, 1000 minus. Yes, this will be more convenient. So let's try to make this 9 instead of 1. Yes, do you understand that why 9? Why not this particular pattern? Understand? Because having four terms will not be able to simplify. Two terms can be managed, and I will show you how we can manage them. Clear? So let's try to make them 999s. So for making them, so let's multiply it by 9 and also divide it by 9. Okay. So now we will keep this 9 outside, multiply the 9 inside. 999 plus 999 plus 99999 and up to n terms. Okay. So 7 by 9. Now this 9 can be written as 10 minus 1. This can be written as 100 minus 1. This 999 can be written as 1000 minus 1. Do you agree? इतनी बात समझ में आई? Is this clear? That 9 can be written as 10 minus 1. 99 can be written as 100. Clear? Great. So if we observe here, minus 1 is getting subtracted for how many times? This is going to up to n times. If this thing is going to get repeated n times, so minus 1 is getting repeated for n number of times. So now we may write as 10 plus 100 plus 1000, and plus it is happening for n term n times, and also minus 1 is getting separated by n times. So if we are writing minus 1 for like minus 1 n times, so instead of that we can write minus of n. Clear? If we are adding 1 plus 1, 1 plus 1 plus 1 plus 1 5 times, so it is 5, right? So if we are adding 1, 1, 4, 5, n number of times, so we may write it as n. Similarly, for negative, we may write minus of n here. Clear?
Yes, sir.
Yes. If there is any doubt, please ask. Let me better represent it. So what is happening is 10 plus 100 plus 1000. Now these numbers will get added for n number of times. And also minus of 1 is going to get added n number of times. So now we may write it as like 100 is what? 10 square. 1000 is what? 10 raised to power 3. So this is basically a GP having common ratio as 10. Great. Now we have cracked it. So 7 by 9, the GP having 10 as its first term, and also 10 as its common ratio. So the formula for n terms is a into 1 raised to power r raised to power n on 1 minus r when r is less than 1. Otherwise, a into r raised to power n minus 1 on r minus 1 and r is greater than 1. R is here greater than 1 as it is 10. So let's apply the same formula. R is 10 raised to power n minus 1 upon 10 minus 1. Okay. Plus minus 1 into n, that makes it minus of n. Clear? Any doubts? Any doubts that how have I written so?
No, sir.
Now this is your answer. We can simplify it further. Seven by 9. 10 into 10 raised to power n minus 1. 10 minus 1 becomes 9 minus of n. Let's take 9 into 9 becomes 81. 7 into 10 raised to power 10 into 10 raised to power n minus of 1 minus of 9. This is the answer. Simple. So please go back and observe that how we have approached this question. Why is particularly every step is taken, like why I have written in this format. Then why particularly multiplying by 9? So that we will be able to express these terms in form of these two numbers, and we'll be able to form out a sequence which we are acknowledged to, which is a GP. Great. So please have a look on this solution. When done, please tell me.